It's getting harder to find a modern gadget that does not use a battery. The most popular batteries are lithium-based, but scientists have discovered a new material that will significantly increase the driving range of electric cars: sodium. One company is now about to unleash the sodium ion on the market, and many experts predict that it changes the game completely. Which manufacturer is making the battery? How does the sodium-ion battery work? And what advantages does it have in the auto industry? The earliest cars in the history of electric vehicles had to make do with the lead-acid battery, known for being heavy, taking longer to charge, and lasting only a couple of years. However, the industry has moved on to another type of battery, the lithium-ion. While it is true that lithium-ion batteries are better, EV makers still see room for improvement. For example, lithium-ion batteries are expensive. They are so costly that they determine the actual cost of the car. There is no denying that battery prices have dropped significantly in recent times. The average price fell from $1,200 per kilowatt hour to just $130 per kilowatt hour. However, the cost is still high, as a price of around $100 per kilowatt hour will bring EVs into the same price range as ICEs. But what exactly is the reason for this high price? The culprit is the cathode, the positively charged electrode. When your car discharges the battery, both electrons and positively charged molecules, that is, the lithium ions, flow from the anode to the cathode, which stores both until you plug in the battery to charge again. So basically, your cathode determines the performance, range, and thermal safety of your battery, and by extension, the properties of the EV itself. As such, the cathode is a crucial component. Cathodes are made from multiple metals, which depend on the cell chemistry adopted by the manufacturer. The most common combination involves lithium and nickel. A modern EV can contain a cathode that is made from lithium iron phosphate, or LFP, lithium nickel manganese cobalt, or NMC, lithium nickel cobalt aluminium oxide, or NCA. Thanks to the boom in EV sales, auto companies are scrambling to secure a supply of cathode materials, and this is driving up prices. However, when it comes to EV lithium-ion batteries, there is an important question that is moving researchers and battery makers like Tesla and CATL to act with speed. The question is, how long will the world's lithium supply last? Here is the concern. Like most elements found on the Earth's crust, the supply of lithium is finite. But the impending explosive growth in EV sales is having battery makers scratching their heads because of how to source lithium. In an average car battery, you will find 10 kilograms of lithium. Multiply that by the estimated 3 billion cars that will be on the road by 2050, and you will see the huge squeeze that will be put on the global supply of lithium. As a study pointed out, lithium availability can become a serious threat to the long-term sustainability of the transport sector if nothing is done about the situation. While some experts have been promoting recycling old EV batteries so that the materials could be used to make new batteries, CATL, a Chinese battery giant, is making a different approach. It is looking at substituting the materials. In the place of lithium, the company is using sodium. CATL has made a huge breakthrough in sodium-ion batteries after many years of research. What makes sodium suitable is that it's similar in many ways to lithium. Sodium ions shuffle between the cathode and anode. The only difference is that compared with lithium ions, sodium ions have a larger volume and higher requirements regarding structural stability and the kinetic properties of materials. This has been a major stumbling block for many companies that are also working on sodium-ion batteries, but CATL has been able to work around it. So why use sodium in place of lithium in an EV battery? There are multiple reasons. Sodium-ion batteries offer superior environmental credentials, enhanced safety, and better raw material costs than lithium-ion. In addition, sodium-ion batteries also promise strong performance, and continuous improvements in density and cycle rate are making the chemistry particularly exciting. Another advantage sodium has is that it is 1,000 times more abundant than lithium, so there is no immediate risk of running out of sodium. Also, the overall cost of extraction and purification is far lower. Generally, sodium-ion cells are priced between 20% and 40% cheaper. In terms of cathode materials, CATL has applied Prussian white material with a higher specific capacity. The company also redesigned the bulk structure of the material by rearranging the electrons, which solved the problem of rapid capacity fading upon material cycling. In terms of anode materials, CATL has developed a hard carbon material that features a unique porous structure, which enables the abundant storage and fast movement of sodium ions, and also an outstanding cycle performance. Even with this first generation, CATL is already reporting impressive results. The new battery has the advantage of high energy density. It also charges fast and boasts excellent thermal stability, great low temperature performance, and high integration efficiency, among others. CATL's sodium-ion battery has up to 160 watt-hours per kilogram energy density. Will also charge to 80% from zero in just 15 minutes at room temperature. This will fix one of the major complaints about electric cars. Typically, EVs spend close to an hour to charge the battery, which doesn't go well with long-distance travel, where you have to stop multiple times to charge. But a 15-minute charging time is far more manageable. There is another significant advantage of its sodium-ion battery that CATL is touting. That is low-temperature performance. EV drivers living in colder places know how much of their driving range cold weather can take. However, CATL says its sodium-ion battery has a capacity retention rate of more than 90% in a low-temperature environment of -20 degrees Celsius. The system integration efficiency can reach more than 80%. CATL has also confirmed its sodium-ion battery's thermal stability exceeds the national safety requirements for traction batteries, so you can use this first generation of sodium-ion batteries in different transportation electrification scenarios. It can be flexibly adapted to the application needs of all scenarios in the energy storage field. The transition from lithium-ion battery to sodium-ion battery cannot be smoother. This is because of a reason pointed out by Dr. Qian Huang, the Deputy Dean of the CATL Research Institute. Sodium-ion battery manufacturing is perfectly compatible with a lithium-ion battery production equipment and processes, and the production lines can be rapidly switched to achieve a high production capacity. Huang also made a case for lithium-ion batteries diversifying our path to energy storage. CATL has already commenced its industrial deployment of sodium-ion batteries and plans to form a basic industrial chain a few months from now. The company is actively encouraging its clients and suppliers to join in promoting sodium-ion batteries. For the next generation of sodium-ion batteries, CATL is working on an anode-free metal battery technology. The company filed a patent named NA Metal Battery Electrochemical Device, in which the metal layer formed on the negative current collector after the first charging is completed is used in place of the negative electrode. The absence of the anode from the manufacturing process and its creation after the battery is assembled and charged for the first time is a novel approach. CATL not only laid out relevant material design patents, but also took the lead in applying for production process patents, indicating that the research progress on this technology has advanced. CATL's goal for the second generation of the sodium-ion battery is to exceed an energy density of 200 watt-hours per kilogram. For practical purposes, CATL will at least initially make sodium-ion technology complementary to lithium-ion. Since the two battery technologies have much in common in terms of structure and working principles, they can be used for the same application, like electric vehicles and power storage solutions. A CATL spokesperson said the company has rolled out an AB battery system solution, which uses both sodium and lithium-based cells in one EV pack. This helps to leverage the benefits of both chemistries and opens up more room for application scenarios for sodium-lithium battery systems. The system compensates for the current energy density shortage of the sodium-ion cells and benefits from their performance in low temperatures. A battery management solution will control the different battery systems using sophisticated battery algorithms. Sodium-ion batteries are projected to replace some of the LFP shares in passenger EVs into energy storage, reaching 20 gigawatt-hours by 2030. The cost saving alone makes it worth all the trouble. The production of 1 gigawatt-hour sodium-ion cells will save 41% of the material expense compared with LFP cells. Let's hear what you think of CATL's sodium-ion battery in the comments section below.